Now we'll study about fluid dynamics. Dynamics means actually the particles are in motion. It is moving now. Till now the fluids are static. Static में pressure we learned, majorly pressure on, right? Pressure we learned, and Pascal's law we learned, law of flotation we learned. Okay, use that formulas only. Basic formulas are fixed. इका थोड़ा extension आपको थोड़ा करना पड़ेगा, practice में आ जाएगा. Okay. Fluid dynamics we are seeing. In this में majorly we are dealing Bernoulli's का use होगा ज़्यादा. Okay. Okay. Here we have to study two different types of flow we are studying. One is streamlined flow or laminar flow बोलते हैं. Streamlined or laminar flow बोलते हैं. Streamlined flow means, what is the meaning of streamlined flow means? Anything? मालूम है कृष्णा? Streamline means? चलो. A flow of fluid is said to be streamlined or laminar when every particle of the fluid follows the same path as that of preceding particle. एक पार्टिकल ऐसा गया तो दूसरा पार्टिकल भी सेम पाथ में ट्रैवल करने का. Such type of motion is nothing but streamlined path बोलते हैं. Okay. And the streamline do not cross each other. Always streamlined paths do not cross each other. So एक एक पार्टिकल का उसका इसका पाथ एक जगह में ऐसे जाएगा, दूसरा पाथ में ऐसे जाएगा. So it will go like this. देखो, एक पार्टिकल दूसरा पार्टिकल से फॉलो करता जाएगा. एंड दिस इधर पार्टिकल फर्स्ट पार्टिकल इधर जा रहे हो तो ऐसे जाएगा पार्टिकल. इसका प्रीसाइडिंग पार्टिकल आल्सो विल कम लाइक दिस ओनली. दिस कॉल्ड स्ट्रीमलाइन फ्लो. एवरी पार्टिकल ऑफ द फ्लूइड follows the same path as that of the preceding particle. Preceding particle कैसे जा रहे हैं? Same particle इधर जाएगा, आगे जाएगा, same जाएगा. Okay, that is called streamline. That means I can tell in another way also. In such motion, the velocity of the fluid particle is at a given point remains constant in magnitude and direction. At that given point में the velocities are same. At that given point में the velocities are same. But I'll ask one question. In a streamline में total velocity will be same. Huh? Streamline में total velocity is same? No. At a particular given point में, suppose it is having 3 meters per second से जा रहा है. Other particle when it's crossing that point, it should have 3 meters per second only. Another particle which is crossing that point, it has 3 meters per second. Okay. So that point में velocity should be same. But either it can be 4 meters per second also. Okay. So streamline में total velocity is same नहीं है. It can change. But at a given point में the velocity, the fluid particle का velocity remains constant in magnitude and direction also. Such flow is called streamline flow. Such flow is called streamline flow.
So 1 second.
Yeah. Then okay.
1 second. So like, is it compulsory that every particle should follow the same path?
Yes, compulsory.
So but how will we know that?
Streamline flow वही है. उसको Reynolds number बोल के आएगा आके. We can know which type of flow is this.
It follows the same path.
Generally in our portion में in all is streamline flow only.
1 second, sir. I'll just write short form now.
Yeah, लिखो. So velocity should be constant at a given point. Magnitude and direction, दोनों should be same.
Yes, you can go to the next slide.
Yeah. Now second one we have turbulent flow. Turbulent flow क्या है? इसका उल्टा zigzag manner रहेगा. Okay, इसका कुछ fixed velocity नहीं रहेगा. When a liquid velocity exceeds a certain limiting value, एक certain limiting value का exceed होने के बाद that is called critical velocity, the liquid flow becomes zigzag हो जाएगा. And the path and the velocity of the liquid changes continuously, haphazardly. This flow is called turbulent flow. देखो, इसका पाथ इधर जाएगा, इधर जाएगा, इधर जाएगा, इधर जाएगा. This is nothing but turbulent flow. Okay, turbulent flow and streamline flow. Generally, our portion is streamline flow only. Okay. Look a short form. Now the question is how to know that it is turbulent flow ना, streamline flow ना, कैसे पता चलेगा? How to know? By using a concept of Reynolds number. वो number will decide the which type of flow it is. Streamline or turbulent flow. मैक्सिमम ऑल पीवाईक्यूज करने का चैलेंजिंग लेके करो. ऑल पीवाईक्यूज करो 2-3 टाइम्स करने का. स्टार्टिंग में यू कैन सी द आंसर्स वगैरह में. अगेन 1 वीक गैप देके अगेन टाइम है तो फिर से करो. नो प्रॉब्लम. आपको थोड़ा परफेक्शन हो जाएगा. सेकंड ईयर में टाइम नहीं मिलेगा आपको. यू थिंक दैट सेकंड ईयर में करेगा, बल्कि कुछ नहीं है. दे विल फिनिश द पोर्शन. नाउ दे हैव फिनिश्ड एलएन पीपल. नाउ दे आर फिनिशिंग द पोर्शन 12th क्लास में. नाउ दे विल टेल दैट 3 चैप्टर्स इन फर्स्ट ईयर, 3 चैप्टर्स इन सेकंड ईयर. तो 1 वीक की गैप दे देगा. टाइम नहीं मिलेगा आपको. जो दिस ईयर पढ़ रहे हैं वो ही रहेगा आपको. That's why. And secondary chapter is also big only. It's not small. Electrostatics, magnetism, बहुत बड़ा बड़ा chapters are there. So which will decide the nature of flow is Reynolds number. एक number है. That's it. और number के हिसाब से we can tell. Okay, finish.
Yeah.
Now Reynolds number. It decides the nature of flow. It decides the nature of flow. और इसका formula देखो, rho v d by eta. Rho v e by d eta. Okay, suppose मान लो एक पाइप है. पाइप का diameter of the pipe is d. And the water is flowing with some velocity v. इसका density is rho. And eta is the coefficient of viscosity. आगे पड़ेगा viscous fluid बोल के आपको. Coefficient of viscosity eta. We represent as eta. In that case में the Reynolds number दिया है formula rho v d by eta. After calculating, if you get the number which is less than 2000, the liquid flow is called laminar flow or streamline flow. If the Reynolds number is greater than 3000, the liquid flow is turbulent flow. Turbulent flow. And if it is between 2000 to 3000, it may unstable है. मतलब the liquid is unstable. It can change here and there. Unstable बोल के लिखने का. That's it. The nature of flow is unstable. Lesser than 2000, liquid flow is laminar. Greater than 3000, turbulent. And between 2000 to 3000, unstable. माना उधर क्या लिख रहा है, इधर क्या लिख रहा है? You're doing some other work?
No, sir. So now for the coefficient of viscosity, will they given the question or do we have to like calculate it?
No, they'll give the question में. Viscosity. आगे आएगा viscosity में. We'll get that coefficient of viscosity. Eta.
So I'm not writing the experiment part.
इधर कुछ एक्सपेरिमेंट नहीं है. एक ही फॉर्मूला rho v d by
Those
eta.
are the experiments have shown that part.
अरे this one is important. after getting the number, if it is less than 2000, the liquid is called laminar flow. But they'll ask which type of flow it is. How we will decide? After finding the Reynolds number, then only we'll by seeing that number only we can decide. Laminar, turbulent, and between 2000 to 3000 is unstable. Done?
Yeah.
Yeah. चलो क्वेश्चन करो. Calculate the Reynolds number of the blood flowing through 30 centimeters per second through an aorta of radius. This was.
So in the
There is also
in the previous slide, what did they say was between 2000 to 3000?
unstable.
Unstable. Okay.
Blood aorta से plus flow है. Assume blood has viscosity eta is given, value is given, and density is given. What is the nature of flow? After finding the value Reynolds number, you can tell the nature of flow. Chaitanya, you can use calculator also, no problem.
Sir, viscosity is given or coefficient of viscosity is given?
Coefficient of viscosity only. Eta is given. 4 millipascal. Milli means 10 power minus 3, right? Substitute.
So 30 centimeter per second means velocity. Yeah, okay.
Yeah. Convert into meters per second. करो प्रणव. Do. Substitute the values and directly.
Sir, 1590.
Calculator, huh? Okay,
No,
which
sir,
type of flow it
calculator.
is? Oh, calculator used. Okay, perfect number I will give. Okay, so what is that? Which flow it is?
1590 means it's
Yes,
laminar.
laminar flow.
So 1 second.
Yeah, sir, Laminar.
Hmm. Next question without the calculator करो.
Yes, I got it.
Yes. करो. What should be the maximum average velocity? मतलब V is telling to find water of a tube of diameter such that the flow is laminar flow and viscosity of water is 10 power of minus 3, the given. So you
the
can take
answer is 1590, right?
1590. Yeah.
Sir,
Maximum value you can take. 2000 you can take, no problem. For
sir,
laminar.
viscosity of water is coefficient of viscosity.
Or question of viscosity only.
Okay.
Eta only.
Sir, 0.1.
So what should we take density as 10 power
Sir, I
3?
didn't
Yes.
use calculator, sir.
Okay.
The density
Yeah,
should I take
you
it as
can-
1 or 1000
No, it is gram or centimeters. Tell me.
centimeters. So
Ah.
1000.
Kgs means 1000, 10 cube.
Oh, so 1 I have to take.
देखो eta also you are taking Pascal's SI units में. You convert it to meters always, and 1000 you should take. All you should convert into meters.
So it will be 1000 into 2 by 100 into V divided by 10 power 3. Is it 10 power minus 3 or 10 power 3?
10 power minus 3.
Okay.
So 0.1.
Yes, 0.1 meters per second is the answer. Yes. Samaya?
Yeah.
Okay. So we studied two different types of flows: streamline flow, turbulent flow, and we how to calculate also we studied by Reynolds
0.1 or 0.1?
0.1.
Yeah, okay.
Okay, chalo. Now next one is equation of continuity. Equation of continuity, which is nothing but law of conservation of mass. Equation of continuity is nothing but law of conservation of mass only indirectly. So what is equation of continuity? Anybody? What is equation of continuity? सुनोगा ना डायनामिक्स में?
Sir, A1 V1 equal to A2 V2.
नहीं, that is a statement. Huh?
So that's what sir wrote.
No, wrong. A1 V1 किया तो wrong हो जाएगा. देखो, it says that in an incompressible steady flow, the mass of fluid entering per second into pipe is equal to mass of fluid leaving per second. कितना mass of fluid per second में enter हो रहे हैं, उतना mass of the fluid coming out. That is only equation of continuity. Continuity should be there. Okay. So mass of, that is only, देखो law of conservation of mass, that one, right? The mass of fluid entering per second is equal to mass of fluid leaving per second. This is the actual definition of the equation of continuity. उधर से only आपको A1 V1 equal to A2 V2 आएगा. But directly we should, sometimes आप questions पे इसमें mistake होने के chances रहेगा. So mass of fluid entering is equal to mass of fluid leaving. That is called आपको equation of continuity. We'll derive also how we get that one. Okay. एक पाइप है, यूनिफॉर्म क्रॉस सेक्शन पाइप है, इसका एरिया A1 है, इसका एरिया A2 है, इसका वेलोसिटी V1 से जा रहा है, इसका वेलोसिटी V2 से जा रहा है.
So I need to draw the diagram.
No need. But understood right? वेरिएबल क्रॉस सेक्शन का करो. हो गया?
Yeah.
किसे डन? Okay. now
Yes,
देखो, now देखो, we'll do the derivation also in this में. देखो, suppose मान लो consider an incompressible fluid in time delta t I'm calculating. In delta t time में मान लो इधर से इधर तक आया liquid and same mass it should come, right? So mass is what? Mass is density into volume. Okay. मालूम है density into volume. Volume कितना होगा tell me? See, density into volume. Volume of this in delta T में कितना volume of water coming? Tell me. Volume कैसे आएगा? Area into length, right? Area into length, and length is nothing but distance only. Distance is nothing but speed in time. Speed in time. So देखो, mass of entering fluid is equal to mass of leaving the fluid, right? So entering fluid का density into volume, right? Volume is area into length. Length is nothing but velocity into delta T. Similarly, mass of leaving from the container. So density into volume. Volume is area into length. Length is nothing but V2 into delta T. So delta T cancel. Rho cancel. A1 V1 is equal to A2 V2, which is constant always. मतलब indirectly, A is inversely proportional to, or velocity is inversely proportional to area. किधर भी area कम है तो velocity of the fluid will be more. Okay. On the videos. A1 V1 is equal to A2 V2 we have to use in the equation of continuity में. From this velocity is inversely proportional to area.
still 1 minute. I'll switch it on.
Yeah. Velocity is inversely proportional to area बोल के देखा होगा ना? किधर देखा? Where will in daily life में anywhere you saw area is inversely proportional to velocity. An example you can give where area is inversely proportional to velocity.
So
Tanvir,
friction.
Friction में क्या है? Velocity का क्या लेना देना?
But if like it's covering more surface area, then it'll go more slower.
नो फ्लूइड में बोलो, लिक्विड में, फ्लूइड में, वी आर एंटरिंग इनटू द फ्लूइड, राइट? देखो आपको ओल्ड डेज में गार्डनिंग में यू सॉ होगा ना, आप पाइप लगातार पानी डाला कभी? You put a gardening anytime, the gardening time, suppose your brother is flowing going there, so आपको उसको ऊपर डालने के लिए क्या करेगा? टेल में व्हाट यू विल डू? पाइप को, सपोज योर ब्रदर इज गोइंग देयर, आप पाइप में पानी है, यू वांट टू थ्रो द वाटर टू हिम, व्हाट यू विल डू? यू विल प्रेस दैट नॉजल, राइट? ऐसे प्रेस करेगा, प्रेस करने से क्या होगा? ये दूर जाके गिरेगा उसके ऊपर. So what you do, the lesser the area, more the velocity. Inverse relation, देखो, lesser the area, more the velocity. Inverse relation. In the normal life में आ रहा है ना, this one equation of continuity, right? So A1 V1 equal to A2 V2 is always constant. From where we got mass of the fluid entering per second is equal to mass of the fluid leaving per second. This is nothing but equation of continuity, right? Now देखो इधर units of AV क्या होगा? एरिया इंटू वेलोसिटी का यूनिट्स क्या होगा? एरिया इज मीटर्स पर सेकंड, मीटर स्क्वायर इनटू मीटर्स पर सेकंड, सो मीटर क्यूब पर सेकंड. एंड इसको क्या बोलते हैं मालूम है? वॉल्यूम फ्लो रेट बोलते हैं. ऑलवेज याद रखो, व्हेन एवर दे आस्क फाइंड द वॉल्यूम फ्लो रेट, नथिंग बट सिंपली एरिया इंटू वेलोसिटी मल्टीप्लाई करना पड़ेगा. एंड वी रिप्रेजेंट वॉल्यूम फ्लो रेट को क्यू. क्यू इज इक्वल टू एरिया इंटू वेलोसिटी. दे विल आस्क what is the volume flow rate here, means आपको area into that particular velocity multiply किया तो volume flow rate आएगा. मतलब volume flown per second, एक सेकंड में कितना volume of water is flowing, we can calculate by using this one, area and velocity. आया? Copy.
Just 1 second. Sir, wait. Sir, over here, V is velocity, right?
V is velocity.
Sir, why is it? Okay, never mind.
देखो AB is constant, right? If you send this side, velocity
Yeah,
is
understood, yeah.
and volume flow rate is Q is equal to A into V.
Yeah, sir.
Yeah.
Sir,
Whenever
V is
they ask,
velocity.
tell. When the area is more, velocity is less. So volume flow rate means area into velocity is called volume flow rate. Then, copied. चलो. So आ गया ना A1 V1, ये वाला this equation is the basic equation. आपको हर क्वेश्चन में suppose area will be given, velocity will be given, area will be given, velocity will tell to find. एक particular cross section है. Always use A1 V1 equal to A2 V2. Valid everywhere, valid. There is no thing because our ideal fluid is incompressible, non-viscous, irrotational वाला fluid only we are talking about. So A1 V1 is always equal to A2 V2. Okay? चलो. हो गया? Copied? करो. Numericals. देखो पानी इधर से आ रहे हैं, इधर भी जा रहे हैं, इधर भी जा रहे हैं. Okay, he's telling given that rate of discharge means Q value is given this much. He's asking determine the velocities of water in the remaining two pipes. Two pipes में velocities कितना है बोल के कैलकुलेट करो. Solve and tell the answer. Radius is given in each pipe का. Velocity flowing in the pipe of 3 centimeters and B 5 centimeters per second. Determine the velocities of water in the remaining two pipes. So आपको क्या करने का? Mass of fluid entering per second is equal to mass of fluid leaving per second. That means I can write A1 V1 is equal to A2 V2 plus A3 V3. I can write like this. Okay.
Why? Oh, got it.
Mass same, right? Density into volume, density get cancelled. A दोनों equal. So I can write like this. A1 V1 is equal to A2 V2 plus A3 V3. Mass of fluid entering per second is equal to दोनों मिलके mass of fluid leaving per second. Calculate nicely and tell.
So what does rate of discharge mean?
Q value.
Oh.
वॉल्यूम फ्लो रेट, वॉल्यूम फ्लोन पर सेकंड है, उसको डिस्चार्ज भी बोलते हैं.
Sir, in the remaining two pipes, they already gave one pipe's velocity.
One
no?
pipe का velocity is given.
So we have to find the other one.
Oh, other pipe का. Yes. No, 1 minute. V1. V1 is not given. मतलब इसका velocity दिया क्या? नहीं दिया ना. इसका velocity not given. And one pipe का velocity
Sir,
is given.
A1
okay.
V1 is 600 pi. So can we just write A1 V1 equal to 600 pi?
A1 V1 is 600 pi. Because area into velocity is called discharge, right? Discharge is same, right? Here. You can equate and solve. पूरा मिलके A1 V1 is nothing but total बड़ा total है ना, total discharge is Q. This is Q. Now solve 6 A1 V1. A1 A2 we know, right? Pi r square, you can take the circle area. Pi r square you can use and tell the answer.
Sir, I'm getting 22 point something and 6.
Yes, correct.
Sir, centimeter per second.
Yeah, centimeter per second. Yes, correct. देखो टोटल फ्लो और डिस्चार्ज इज Q का वैल्यू इज A1 V1, राइट? ये दोनों से V1 आ जाएगा.
Sir, I got 22.2.
Sir, I got 22.16. Yeah, got it.
Yeah. And V1 is how much? V1 कितना है? मतलब this one,
Six.
V1. 6 आएगा. आया? See, simply equate this two, you will get V1. Now you can equate this with this one. You will get an equation. आया?
Yeah, got it.
करो. JEE में क्वेश्चन करो. The ideal fluid through a pipe of non-uniform diameter, the maximum and minimum diameters are given to you. The ratio of minimum and maximum velocities of the fluid is. Area ज़्यादा will be have minimum velocity, right? Inverse relation.
Sir, 9/16.
देखेंगे.
So 1 second.
Yeah.
So 9/16.
Yes. mana bolo. So A1 either area small, diameter small. What? A1 V1 equal to A2 V2 only, right? A1 is pi d square by 4. Diameters are given, right? You can use. Okay. numerical based 2023.
So I got 80.
देखेंगे. Liquid being pushed out of the tube of piston of area of cross section 2 meters centimeter square. The area of cross section outlet also given, and the piston speed is this much, and the speed of the outgoing.
So sir, I forgot to convert the centimeter square into millimeter square.
Correct. All
Sir,
centimeters
how
square.
do you
80.
convert it?
1 centimeter,
80.
1 milli. Huh?
80. No, wait.
Uh,
Oh, wait. I go given millimeters. 1 second.
See, 1 millimeter and centimeter का क्या
Oh,
relation
that
है?
doesn't matter.
1
Sir, it's
centimeter is 10
centimeter is
millimeter.
10 millimeter.
10 millimeter. Convert कर लो.
Sir, won't it
Oh.
be the same thing?
What? You convert into millimeter to centimeter, right?
So,
Sir,
10 into 10
I converted
2.
centimeter to millimeter. It'll be easier.
Anything, because cancel हो जाएगा ना दोनों. See, आपको shuttle में which one you want to convert
millimeter.
to centimeter? So 10 millimeter is given as 10 power of minus 2 centimeter square.
Oh. Okay, sir.
Because whole square है ना, that's why 10 power minus 2. बोलो क्या इजी क्वेश्चन बोल के दे यूनिट्स दे विल गिव वांटेडली. तो कितना है आंसर?
80, sir.
80 centimeters per second. Yes, that is answer. आया? Next. That's why they are playing with the units, because answer easy question बोल के.
Sure, can we use calculator?
మరి मेंस क्वेश्चन वो लोग कैलकुलेट देगा. अप्रॉक्सीमेट ट्राई.
Okay, sir.
Question understood, Manav?
Yeah.
Cylinder tube has a spray of cross section area. ऐसा areas are there, 50 holes are there.
Meters per minute. So, I have to convert into meters per second.
Per second by 60 करने का.
0. Okay.
The speed of the liquid ejected through the holes is. इसका velocity is how much?
Sir, I used calculator and I got
Yeah.
it.
कैलकुलेटर मत यूज करो, ट्राई करो, जेई में क्वेश्चन है ना, व्हाट टू डू.
Yeah, sir, I got it with calculator.
ओके,
So you did
कितना है आंसर? 0.19
0.19.
देखेंगे
0.19.
देखेंगे.
Sir, 1.9.
1 पॉइंट ऑप्शन नहीं है.
Sir, 1 point. Oh, meter per second.
हाँ,
Sir,
तो ऑप्शंस भी देखे तो समझ में आएगा फर्स्ट में. एंड हियर आल्सो यू कन्वर्टेड अगेन सेंटीमीटर, राइट? मीटर्स पर सेकंड को यू कन्वर्टेड इनटू सेंटीमीटर. All should be in
yeah,
same
sir, I
unit.
did that into centimeter per second. It's
Okay,
centimeter.
centimeter per second means directly you can convert into meters per second, right? Divide by 100 करो.
Divide by 100.
हाँ,
Okay, so 0.19.
0.19 is answer. हाँ, yeah, Pranav, you got?
So,
करो.
so 12 into 1 by 40 is equal to 50 into pi into 1 by 100 into v, right?
हाँ, कट. So ये पूरा सॉल्व
Yeah.
किया तो you'll get as 0.19 meters per second.
Yeah.
Okay, चलो. Now we'll go for Bernoulli's theorem. Bernoulli's famous theorem. Bernoulli's theorem. What is Bernoulli's theorem says? Anybody? मालूम नहीं है?
So that half rho v square, right?
पूरा बोलो. Only after we square, हाँ? Krisha? हाँ.
So one rho g is there, I know.
Okay. Bernoulli's theorem.
So rho g1 plus rho g2 plus half rho v square is constant.
Okay, मतलब what is that conclusion, that what is that half rho square or is p? Okay, चलो, we'll see.
So that's the kinetic energy.
No, wrong. Anybody? चलो. It states that for an ideal fluid में, which is incompressible, non-viscous, steady streamline flow, the pressure energy, kinetic energy, and potential energy per unit volume, all are per unit volume, remains constant along the streamline flow. What are, मतलब indirectly total energy per unit volume in a streamline flow is constant. This is a definition of the Bernoulli's principle. कौन सा एनर्जी है? सपोज वेरिएबल क्रॉस सेक्शन का पाइप रहेगा. ये हाइट h1 है ग्राउंड से, ये रेफरेंस लाइन से कितना h2 हाइट है. इधर p1 एंड वेलोसिटी इज v1 एंड p2 प्रेशर per energy, actually pressure per unit energy and pressure per unit volume, actually this is, and v2 is a velocity. Now in this case mein, what is the Bernoulli's theorem says that pressure energy per unit volume, which we represent as p, and this is what kinetic energy per unit volume, and this is potential energy per unit volume, is always constant throughout the cross section area. मतलब here the total energy is always constant. Total energy per unit volume is constant. देखो suppose example, kinetic energy का फॉर्मूला क्या है? हाफ mv square.
V square.
Okay, but I want kinetic energy per unit volume, right? Kinetic energy per unit volume means by volume लगाओ. What is mass by volume? Nothing but density. So that's why half rho v square. So half rho v square is not kinetic energy per unit volume. So ऐसा derivation रहेगा इसका. P is not pressure energy per unit volume. Okay. So all energy per unit volume is always constant throughout the cross section. So whenever you are applying, we can apply total energy per here and here equate करके we can solve whatever you want. लिखो मानो.
No, sir, I'm trying to first understand it.
See, books padna after class mein you can read other book whatever you want to
Sir,
read.
so at
Ah.
2 points, will it be the same?
Yes, not only 2 points, every point mein
So
everywhere.
P will always be same, right? At all points.
P is pressure energy per unit volume. Pressure is not same. But when you are applying, कैसे apply करने के मालूम है? Suppose 2 points में P1 plus half rho V1 square. V is also not same, right? And
Yeah.
plus rho G H1 is equal to, इसका 2 points में apply करो, कैसा आएगा? P1 plus half rho V1 square plus rho G H1 is equal to P2, मतलब first point, second point I'm applying. P2 plus half rho V2 square plus rho G कितना height है? H2. So like that we have to equate and we have to find majorly क्या होगा मालूम है? Majorly we have to find the pressure difference. P1 minus P2 only they will ask. Pressure difference we can calculate by using this Bernoulli's principle. Okay. If you see this value should be constant, right? From this also one conclusion आएगा. As the velocities of the particle increases, what will happen to the pressure? If the velocity of the particle is increasing,
Increase
Pressure decreases.
pressure decreases. Why? Because to make the total values constant. That means inversely proportional, right? Velocity is inversely proportional to pressure. Done, Vidya?
Yeah.
Okay. So what is the Bernoulli statement? That total energy per unit volume is constant always. Okay. In different forms में भी है, different forms में है, वो भी लिखेंगे. But also sometimes helpful. चलो.
So one second. Sir, what does the up arrow indicate in the rho PV square?
Rho
In the
half
P
rho is-
plus half rho PV square up arrow.
no, apparent नहीं है. Actually, as velocity increases, what will happen to the pressure?
Will decrease.
Decrease. So that the total value is constant. That's why increase बोल के लिखा है. So
Oh.
V is inverse proportional to P.
Okay.
Okay.
Yeah,
Done?
done.
Yes. Now, इसका meaning I told that as velocity increases, ये लिखने की जरूरत नहीं है. As velocity increases, pressure decreases. As velocity decreases, the pressure increases generally. And this is the reason where आपको एरोप्लेन लिफ्ट होने के वाला को ये बहुत हेल्पफुल हो. एरोप्लेन ओल्डन डेज में they always नीचे गिरता था. They tried, people died also. They took the wings and they jumped from the top of the mountain also. So that they want to fly like a birds, but they fell down. They broken their legs also. Why? Because उसमें क्या problem है? And who discovered last में Wright brothers बोल रहे हैं generally वो लोग क्या किया? They designed by using the Bernoulli's principle. वो क्या किया? This IP questions also will be there. आपको एरोप्लेन में आपको क्या होगा? विंग रहेगा ना. विंग का डिजाइन चेंज करने से ओनली द एरोप्लेन उड़ना शुरू हो जाएगा. विंग का डिजाइन एरोफॉइल बोलते हैं ना. सो आपको ये डिजाइन अच्छे हुए दैट आपको क्या होगा? वेलोसिटी एंड प्रेशर रहेगा. देखो व्हेन द एरोप्लेन इज मूविंग लाइक दिस, विंग्स रहेगा ना. नीचे का क्या होगा? वेलोसिटीज ऑफ द डिजाइन विंग्स अच्छे हुए दैट द वेलोसिटी ऑफ द पार्टिकल्स इन द बॉटम में, when the velocity of the particles bottom is less and compared to more, ऊपर more है, नीचे velocity of the particles less. If the velocity is particle less according to Bernoulli's principle, क्या होगा? The pressure is more and ऊपर pressure is less. So क्या होगा? There is a pressure difference. Pressure difference की वजह से it will start flying up. There is a drift होगा ना, ऊपर जाएगा. Okay, so because of pressure difference, अगर wings सीधा बनाए तो it will not lift, कभी भी नहीं होगा. आपको थोड़ा एरो ऐसा रहेगा ना, याद है? थोड़ा ऊपर रहेगा, नीचे ऐसा रहेगा, स्लोप रहेगा. सो नीचे वेलोसिटी विल बी लेस ऑलवेज, प्रेशर इज मोर, एंड ऊपर प्रेशर वेलोसिटी इज मोर, प्रेशर इज लेस. सो देयर इज अ प्रेशर डिफरेंस एंड इट विल स्टार्ट लिफ्ट. सो दैट्स व्हाई फास्ट मूविंग एयर क्रिएट्स लो प्रेशर, द प्रिंसिपल बिहाइंड एरोप्लेन लिफ्ट. एंड मेनी एप्लीकेशंस आर देयर. सपोज मान लो ए बर्नौलीज प्रिंसिपल का आपको वेलोसिटी एंड प्रेशर का डिफरेंस आपको समझ में आने के लिए थोड़ा you tell me, 2 papers है आपके हाथ में, 2 papers are there, ले लो, 2 white papers ले लो. ले लो कृष्ण. 2 white papers, simple papers I want. Just ऐसे 2 हाथ में पकड़ो ऐसा, कीप दैट फेस टू फेस, मतलब दोनों में रेक्टेंगल फेस लगाने का। हाँ ऊपर पकड़ो, ऊपर टॉप में पकड़ो, टॉप टॉप ऑफ द पेज। नहीं नहीं, 2 डिफरेंट डिफरेंट हाथ में, 2 डिफरेंट हाथ में। ओके, इन वर्टिकली लगो, वर्टिकली लगो। अरे टॉप पकड़ो, हाँ ऐसे पकड़ो, कृष्ण थोड़ा नीचे करो, नीचे अत्ता फेंकना है। यू फेस ईच अदर लाइक दिस। हाँ ऐसा, मानो ऊपर पकड़ो, टॉप पकड़ो, लाइक कृष्णा राइट। नहीं नहीं, आप करेक्ट हो कृष्णा। ओके, हाँ ऐसे लगो। ओके, हाँ नाउ क्या करेंगे, आई लास्ट फर्स्ट क्वेश्चन देन टेल, डोंट डू एनीथिंग। ओके, इफ आई ब्लो इनसाइड द पेपर कैसा होगा, जाएगा ऊपर जाएगा अंदर आएगा, टेल में। इफ आई ब्लो
So it will
इनसाइड,
go outside.
आउटसाइड,
Go
पक्का राइट।
outside.
ओके नाउ नजदीक, थोड़ा नजदीक रख के ब्लो करो, ब्लो करो, उफ्फू बोल कर, बट जोर से, जोर से, अरे करो नो प्रॉब्लम। हाँ
So it's coming closer only.
हाँ क्लोजर, हम लोग सोचेगा और बाहर जाएगा, इज कमिंग क्लोजर भाई। आपले बनवालिस, बनवालिस, when you're blowing air inside is more or less, inside is more, right? Air particles are more inside, तो क्या होगा, velocity is more, velocity is more में pressure क्या होगा,
Less.
less, outside pressure is more, then क्या होगा, pressure difference create होगा, वो ऐसा आ जाएगा। Okay, so this is a Bernoulli's principle। ये even lift होगा, many applications are there, even IP में there is 2 more questions will be there in this में। So क्या होगा, even हमारा क्या बोलते हैं, huts will be there, right? Normal they will make with a ऊपर they will put all this like this, right? ऐसा they will make like this, घर में ऐसा बनाएगा, ऊपर ऐसा लकड़ी ऐसा बनाएगा प्लेट्स का। तो क्या इनसाइड, when the wind comes, when the wind comes क्या होगा, इनसाइड एयर पार्टिकल्स आर लेस एंड ऊपर एयर पार्टिकल्स आर मोर, क्या होगा, देयर इज अ प्रेशर डिफरेंस क्रिएटेड एंड इट विल कम आउट फ्रॉम, ऊपर से निकल जाएगा। ओके, दिस ऑल एप्लीकेशंस ऑफ बर्नौलिस का। ओके देखो, लिखो,
So we should write all of these.
स्प्रे, ऐसा स्प्रे कर रहे हैं ना, दिस आल्सो बर्नौलिस प्रिंसिपल ओनली, Bernoulli's principle। And lift of the airplane wing, just you write down this one names, that's it। And blowing between 2 papers, देखो we done right, paper move together because of low pressure in fast moving
So is
air।
it compulsory to write the explanation or is the application
नहीं
enough?
all this one लिखो। And these 2 are important, venturimeter and pitot tube। application of Bernoulli's only venturimeter में यूज करने वाला है, measures the rate of flow of liquid through a pipe using pressure difference। so Bernoulli's majorly काम क्या है, to find the pressure difference। अगर प्रेशर डिफरेंस आ गया, फोर्स आल्सो यू कैन फाइंड, राइट? प्रेशर इज इक्वल टू फोर्स पर यूनिट एरिया, फोर्स इज इक्वल टू, प्रेशर इज फोर्स अपॉन एरिया, राइट? नेट फोर्स अपॉन एरिया, सो फोर्स इज प्रेशर इनटू एरिया। सो इफ आई नो P1 माइनस P2, दोनों डिफरेंस आ गया तो इनटू एरिया क्या, तो वी गेट नेट फोर्स। समटाइम्स दे विल कैलकुलेट, दे विल टेल टू फाइंड द नेट फोर्स। सो आपको प्रेशर डिफरेंस वी कैन कैलकुलेट बाय यूजिंग बर्नौलिस प्रिंसिपल and multiply with the area, you will get the net force acting at that place। so low velocity से air particles less है तो fast moving है तो low pressure, for lesser particles means more pressure, inverse relation always। okay, चलो other forms भी लिखेंगे।
1 second.
something पड़ेगा, what you study I don't know, मानो वो study
Yeah, sir, done.
try to learn from that। okay, चलो हो गया मानो, चलो
Yeah.
या चलो now देखो other forms of Bernoulli's principle है. First form is energy per unit mass form. Energy per unit mass form. This also आपको Bernoulli's principle only. आपको क्या करेंगे, डिवाइडिंग द होल इक्वेशन बाय रो से डिवाइड करो, रो से डिवाइड कर रहे हैं. सो आपको क्या है, पी बाय रो आएगा और रो कैंसिल हो जाएगा एंड रो जी एच बाय रो इज कैंसिल हो जाएगा. दिस इज एनर्जी पर यूनिट मास फॉर्मेट में, एनर्जी पर यूनिट मास फॉर्मेट लिखो. आपको किधर यूज होगा बाद में समझ में आएगा. एनर्जी पर यूनिट मास पी बाय रो प्लस हाफ वी स्क्वायर प्लस जी एच इज इक्वल टू कांस्टेंट. So sometimes आपको they will ask the dimensions of pressure energy per unit mass. So we have to calculate ऐसा.
Sir, our
Okay.
sir told that we need to remember the derivation of the Bernoulli's.
नहीं नहीं, नो नीड ऑफ कुछ किधर यूज नहीं होगा. This is one form. Second form also is there. Done? Huh? Yeah. Second form is there. Energy per unit weight form. आपको weight का
Srivansh,
क्या?
can you show that?
This is
Okay,
energy
sir.
per unit mass. Okay. इधर क्या होगा, एनर्जी पर यूनिट वेट वी आर डूइंग. आपको क्या करेंगे, डिवाइड बाय रो जी इन टोटल एक्सप्रेशन में. दिस इज प्रेशर हेड बोलते हैं एंड दिस इज वेलोसिटी हेड, दिस इज पोटेंशियल हेड. सी ये कैसा यूज होगा, टेल यू. कैन यू टेल मी व्हाट इज द डायमेंशंस ऑफ प्रेशर हेड? हु विल डू फर्स्ट, टेल मी डायमेंशंस ऑफ प्रेशर हेड. आई वांट.
So it will be just the volume, right?
Pressure head means this one.
So it will be meter cube.
The dimension means MLT wala.
Oh, L3.
Wrong.
So L to the power minus 3 into T.
Wrong.
So it's L1, I think.
Yes, correct. देखो.
Sir,
So what is
compare
1?
pressure as rho Vg.
हाँ
Compare pressure as rho Vg.
देखो, यू आर कैलकुलेटिंग द एक एक प्रेशर का सेपरेट डायमेंशन, रो का सेपरेट डायमेंशन लेकर है ना. आपको वी लर्न इन द यूनिट्स एंड डायमेंशंस में दैट ईच टर्म का डायमेंशन शुड बी सेम और नॉट. ईच टर्म का डायमेंशन शुड बी सेम. सो
Yeah.
प्रेशर हेड का डायमेंशन इज इक्वल टू इसका डायमेंशन इज इक्वल टू इसका डायमेंशन. एच का डायमेंशन इज एल इज सेम. समझ में आ रहा है? Dimensions, we cannot add this equation, right? We cannot add rupees plus some height. We can add this one, we can't add, right? This equation is right means each dimensions ka equations are same, each dimensions ka same. Okay, that means iska dimension is equal to iska dimension is equal to iska dimension. So iska karne ki zarurat nahi hai. Only h ka dimension is equal to the pressure head dimension and h ka dimension is also equal to the head dimension. This is the advantage of having. So L बोल देने का, that's it. Length.
Sir,
लिखो.
then this equation is wrong, sir.
नहीं आप wrong किया. If you do, he done देखो pressure by rho g किया तो हम बर्नौली आकर मारेगा और wrong बोले तो.
Sir,
Pressure
if
by
you do
rho
the
g
first time, you won't get L, sir.
L ही आएगा. उसका आया ना, मानो.
No,
You
sir,
done
sir, do it now, sir. Sir, you won't get L, I'm telling
So you
you.
get pressure, sir. Pressure is
force into
ML,
area.
yeah, ML inverse T to power minus 2.
ML T per minus 2 into L square. Area is L square.
Sir, T power minus 2.
फोर्स का फॉर्मूला क्या है?
Sir,
Mass
force
into acceleration,
by
right?
area, no? So it
See.
will be
एरिया इज मीटर स्क्वायर टी स्क्वायर एंड एल स्क्वायर, राइट? ऊपर क्या आएगा? m l इनवर्स t पर -2, राइट? हाँ, वो मिस्टेक है, बर्नौली को बोलते हैं, बर्नौली.
no, sir. Right only I was wrong. Continue, sir.
By density is mass by volume, so ml power -3, right?
L power -3.
अरे मरे.
Okay, sir.
Yes, so these advantages of having, okay. तो these आपको आगे का हम लोग क्या करने वाले हैं, इसका क्वेश्चंस करने वाला है पूरा.